Limiting reagent problems are ones in which you're given amounts of two different reagents. You need to determine which is the limiting reagent and which is the excess reagent. The excess reagent will have a little bit of it left at the end of the reaction. The reaction stops because you run out of the limiting reagent, and therefore the limiting reagent determines the maximum amount of product that you can form, because at the end of the reactions it's all consumed. You already know how to do a limiting reagent problem. Consider making brownies. If you have 5 brownie mixes and 6 eggs, and each mix calls for 2 eggs to make a batch, you immediately determine in your head that you can make 3 batches and that there are 2 boxes left over. In the language of chemistry, the brownie mixes are the excess reagent because there's a bit left over when the reaction's complete, and the eggs are used up. They're the limiting reagent. They limit the amount of product that could be formed. If we had more eggs, we could make more brownie mixes. But we don't, so we're limited to only 3 batches. Now, what we're going to do is to formalize a thought process so that you can apply the same thing, the same thought process, to a chemistry context. Here's the process. We're going to initially do 2 calculations to determine how much product could be made if each reagent were completely consumed. First, we need a balanced chemical equation. I'm going to say that a box plus 2 eggs is going to give us a batch of brownies. Now, we said that we have 5 boxes and that we have 6 eggs. So we're going to do 2 calculations to determine how much product could be produced from each reagent. In the first case, we have 5 boxes. Our balanced equation tells us every box is going to lead to the production of a batch. So if all the boxes were used up, we would have 5 batches. Now let's look at the eggs. We started with 6 eggs. Our equation tells us that we need 2 eggs for every batch. That means that 3 batches can be produced. So all we've done here is we've used this as a balanced chemical equation. Now, in reality, we know that we would never get this far because we'd run out of eggs first. So our max product is 3 batches. This is the smaller amount, but it's going to be our max product because we know that we'd never be able to get here. We'd run out of our limiting reagent. Once we produce 3 batches, we'd never get to 5 batches. The reagent that leads to our max product is our limiting reagent. And in this case, that means it's eggs. Eggs are our limiting reagent. The other reagent is our excess reagent. So we've answered our first question. We've answered how many batches of brownies we could make. The next question is how much of the excess reagent is left over. To answer this question, we use our limiting reagent to calculate how much of that excess reagent is consumed and then subtract that amount from the initial amount. And that's what we've done here. We start with our limiting reagent, the eggs. Eggs are our limiting reagent. We compare it to our excess reagent through our balanced chemical equation. It tells us 2 eggs are needed for every box. So now we know that 3 boxes have been consumed. And all we need to do is subtract to find out the amount of excess reagent that's left unconsumed. And that's what we've done here. We've started with our initial reagents, subtracted out the amount that's consumed, and we know how much is left. So all we need to do is to take the same process and apply it to problems in a chemistry context. We do two calculations to determine how much product can be formed from each reagent. We choose the smaller of the two product amounts as our max product. That identifies our limiting reagent. The other reagent is thus the excess reagent. If we want to find out the amount of excess reagent that remains, we calculate how much is consumed by comparing it to the limiting reagent. We subtract the amount that's consumed from the initial amount, and we have the amount that's left unconsumed.